Welcome to this very last session of this very fabulous open source event. It's really what an incredible lineup. Thanks for organizing this. I wish I would have more customers doing so much open source culture promotion, inner source promotion. Really, really, really nice. And actually, I'm also a little bit proud that Red Hat was also part of the very first of these long-lasting, several years events. So I'm now your last session. So if we would be on site, I would make this really short because I have the last session between the dinner and the party. But yeah, I hope you see us later at the bar. I will be joining. I love this bar setup. It's really cool. It remembers me on my starting points. So my name is Daniel. I am the account solution architect at Red Hat, looking after Siemens on a worldwide basis. So all Red Hat products on all Red Hat, all Siemens divisions. Quite a journey about the past couple of 3-4 years I'm doing this now. And yeah, I had the same discussion with Roger, but hey, of course I would like to participate. We have a tradition here, I have to. What would you like me to talk about? And so we came up with a nice mixture of, first of all, looking at some technical stuff, because open source is about innovations. And when I thought about what are the two most impressive innovations out of the open source community, which I have seen in the last 1, 2, 3 years, which I think, wow, this is really making a difference. And I would like to tell you that. And for me, it's also always important to really show you the stuff, to do a live demo, because I'm the strong believer of seeing is believing. So that's why I'm not showing much slides, just a little bit to explain, and then let's have a look and see. And then I think I also have to talk a little bit, and that was the other aspect, about the CentOS story. If you didn't notice, in the past couple of, I think, 3-4 months, actually Red Hat suffered from a pretty heavy shitstorm for what we did with CentOS. And I would like to explain a little bit on what actually happened and the why and the consequences and implications it might have for you. That's basically the idea. And then I look forward to your questions, discussions, and of course, having a virtual beer at the bar later. So let's get technical first, shall we? So the really nice impression or innovation I had in the last 2 or 3 years about that Cubeville project. It's about virtual machines and container technologies, because we are all talking about container technology in the last 3-4 years. Yes, containers are important. I'm not sure who it said earlier in one of the sessions. I think it was a chat comment. We have to put everything, Siemens has to put everything in containers within 3 years or we are dead. Turns out, yes and no, it's not that black and white. It's not that dramatic. But yes, of course, container technology has a really huge trend and impact. But hey, virtual machines are not going away. And so it totally makes sense not to make a difference, but to have one single platform where you can have both, best of both worlds, virtual machines and container technology. And that's the initial idea of the Cubeville project. Because if you look, for example, at Kubernetes, Kubernetes in its essence, in the core, is a scheduler. So the job is to place something onto something else. Yeah? And actually that doesn't matter if it's a container or a virtual machine. It's just a different size, right? It has different CPU characteristics, different RAM, but in essence, it is more or less the same. So in the core of the platform, the core Kubernetes job doesn't care. So it makes sense. Now, how does it look like? How does it work? So basically, the idea is you have an operating system where you have virtualization technologies and containerization technologies, and you have Kubernetes, and you put then containers and virtual machines on top of it. So you can really easily for example, take your existing workload and then modernize it, take some functionality out of the monolithic application and put it into a microservice. So that's the whole idea. And how it actually does work is that we have an operating system and we have Cubeville and we have a surrounding container. And in that container, actually, KVM is running. QEMU, KVM, libvirt, you know that stuff if you are looking into open source virtualization. And actually, the core virtualization technique, the hypervisor, is not new. KVM is like 10, 15 years old. It's well known. At Red Hat, we have it in different flavors. So we have Red Hat virtualization, which is based on Ovirt, is the upstream community project to do the management of that stuff, or we have it in OpenStack. So what we basically did, and actually also the Cubeville project, is we took this well-established project and put it into Cubeville and make Cubeville aware of that, to make it schedulable, make sure that KVM is deployed to that node. And so you can run a virtual machine in your container platform. So, and as I said, seeing is believing. Let's do this. So we switch over to my container platform. So this is Red Hat OpenShift container platform. This is our Kubernetes distribution. So you can do the same with OKD and Kubernetes. So upstream is everything there. It's just our enterprise distribution, and I log in as administrator. And here you can immediately see on the overview page already this virtualization tab. So what you actually do is to add virtualization support to your Kubernetes cluster is you use the CNV operator. That's basically how you tell the platform that you would like to use virtualization techniques. And of course, what you need is bare metal servers, because that's best. And let's quickly look what I have here. If I go to my compute tab and see how does this cluster look like, here you can see that this cluster actually has 4 nodes. 3 nodes make the control plane, and I just have 1 worker node, which is really bare metal, and you can see that it is bare metal just on the size of the RAM, because it has 768 gigabytes of RAM and actually 42 cores, something like that. So it's a really big bare metal machine. Why do I need bare metal machines? Because I would like to run a hypervisor. If you would take, for example, a worker node which is already virtualized, let's say VMware, then you have a virtual machine running in a virtual machine, which technically works. You can make this run, but of course it's slow like hell. And in the long term, for production environments, at least Red Hat does not support this. For proof of concept, demo, tryout environment, fine. There are instructions how to do this, but I would say let's stay away from that. So that's my infrastructure. So I have a bare metal cluster. It's, by the way, running in Munich in our internal data center. And if you apply and if you add this virtualization operator to it, you can see that actually virtual machines are nicely integrated here. So there's my pods, that's my container technologies. And here I have virtual machines. Yeah? And I have to switch over to the right namespace and switch over to CNV, Container Native Virtualization. And here you can see there is a virtual machine running. And the nice thing of this approach of first having the surrounding container and putting KVM and the virtual machine inside that pod makes the virtual machine a first-class citizen in the platform. So all the mechanisms like role-based access control, who is allowed to change this? It's the same mechanisms. Networking, how do you, for example, have a pod access a microservice running in that virtual machine, or the virtual machine software connecting to a microservice in a container? That's all using the standard Kubernetes container platform mechanisms. So that is a really nice thing, which, for example, leads to, if I click here on this virtual machine, you get immediately the same what you like to see from your container, like what's the utilization, memory, stuff. Yeah. And you could even do some cool and fancy stuff like, for example, migrate the virtual machine. Remember, containers cannot be moved while they are running from one host to another. Virtual machines usually can. And so actually I could migrate this virtual machine from one host to another to allow, for example, for host maintenance. But as I have only one bare metal node, I actually cannot do this now. So, but here you can see, for example, also the typical virtualization techniques like, hey, let's add additional network interfaces because I would like to pass through an additional network, for example, to connect to my operational technology on the factory floor, or add additional disks to it. Yeah. That is all quite easy possible. And for example, also disk is interesting because here, again, the same mechanisms for container apply. So creating a virtual disk can consume any storage you have attached to your container platform. Could be node local storage, could be software-defined storage, could be cloud storage, whatever you have. Yeah. And now the really cool thing is what really is that, yeah, that when I saw this the first time, that is a really, yeah, I literally got goosebumps on it. If you look into the console, so if you do this with a container, you typically get a shell. And now I have a virtual machine. What do I get to look at the console of the virtual machine? Yeah, I get the output of the virtual machine. So, and as the name already suggests, I put a Windows virtual machine in here, and so I can actually send Control-Alt-Delete. And here you can see there's a Windows virtual machine running in the web console of my container platform. Yeah. And for example, now, wrong password. Yeah, I don't do this. I think it was this one. Ha. I have to focus on the password. Yeah, okay, I did forget the password. I cannot show you that, it's live, sorry. So, yeah, that is really nice. You could RDP into it, you can put whatever workload you have. Usually I use Windows because it really helps in migrating workload to Windows. And just to briefly show you that I was really I'm talking about the virtual machine is running in a container. If we look in this namespace now into the pod sections, here you can see that there is a virt launcher Windows 2019. So this matches my virtual machine name. It's Windows 2019. And the virt launcher pod is the actual container where the KVM stuff, QEMU, and so on is running in. So if I look, for example, here into the log files, you can see that Cubeville is complaining, logging, whatever is going on here. Yeah. So yeah, really nice technology. Really helps in moving to a cloud-native modern platform. Get speed with CI/CD processes because all that fancy stuff you might use for container technology helps here. Also, these virtual machines, and yeah, I think that really helps to get to modern application development. So this is just for the slide deck in case you missed this and you're just watching the slide deck, the documentation. So that was one technology I wanted to show you, and we also we mentioned Quarkus already a little bit. So now completely shifting gears a little bit from the operational virtual machine stuff to really more development focus, and that is something I'm wearing this shirt for a reason. Code is my animal. I started with Java like over 20 years ago. I think it was Java 1.1 or so, and yeah, looking into the Java space, what happened with Java Enterprise and all that stuff sometimes made me a little bit sad. So this Quarkus initiative is a really nice thing. So what does Quarkus is about? The challenge is that there is a need for a new Java stack that is really cloud native. Because if you look into traditional Java stacks, you have rather monolithic applications. So most of the cloud-native greenfield developments are using Node.js, PHP, Go, whatever. And Java got a little bit disconnected simply because it was too big, too fat, starting with startup time, base memory consumption. If you would like to go, for example, serverless, cloud native style, you need really, really small container images with ultra fast startup times, small memory consumption that you can easily scale it up, scale it down. And we heard a lot of this demand, and that is why we started the Quarkus initiative. So the idea of Quarkus is that it's, let's say, supersonic subatomic Java, and that is where the Quark comes from. The Quark stands for this really small particle physics topic. And the us, I think it is just because finding a good name is one of the hardest problems in computer science. So that's why it is labeled Quarkus. So the overall idea is to really create a new Java landscape, which is cloud native, microservices, serverless ready and enabled. Because Java is not going away for the next, whatever, 20 years. I'm always saying, yeah, Java is the COBOL of the 21st century. So it's not going away, but we need to have it a really stunning performance. So really small footprint, small lightning fast startup times. It must be a joy for a developer to work with it. So for example, hot code replace, debug it while it's live, fixing code. Even in a container running in a cloud, you are sitting at your laptop developing, the container image is running somewhere in the cloud. You would like to debug it, fix it. Everything must be lightning fast, and it must be really supporting all these modern frameworks like Camel or Istio, Kafka, and all that stuff, but also the modern cloud native development patterns like CQRS and stuff like that. Event-driven architectures, this whole SOAP pattern. So what we actually did is we really targeting a new virtual machine. And to give you an example for this, so if you look into, for example, the memory footprint of a traditional cloud native stack, like Spring Boot, you need typically a couple of megabytes, hundreds of megabytes of RAM, container image size. If you switch to Quarkus with a traditional JVM, like OpenJDK, it is getting a little bit smaller. And the really nice sweet spot is, and that is basically the major innovation is, if you switch to the Graal virtual machine, what actually happens is that at compile time, at build time, native code is generated. So it's not bytecode anymore, but you're really compiling against a certain platform for a certain target. You get a binary executable, and that's running. Yeah, and that is why it gets so slow and so fast. And yes, compile time is really extending, so it can take like 2-3 minutes to compile something. But that's basically the idea. So it should be Kubernetes native. It should support serverless, event-driven architectures. I was talking about that. So let's get technical again. I have to switch here to my Quarkus project. And let's make, there's no virtual machine running and there's no pod running, which is good because there is a simple, what I did prepare is a simple container image, which actually not I did prepare it, but a colleague of mine prepared it. And we are going to start this up, and you can see that it's just a simple REST service. So what you typically do with microservices, right? They respond to REST calls. Yeah? And I simply deployed here for my colleague Ortwin Schneider a REST image, and we can actually take a look into this image. And here you can see in the registry that the image size is just 50 megabytes. Okay? So it is the whole container image. It's based on our universal base image, RHEL 8 universal base image, and then put the Quarkus application on top of it, and it's just 50 megabytes for a full-blown REST service. Yeah? And now let me fire this up by scaling it up to a one pod. And if we switch over to the pod, you can see, boom, it's already running. Let's take a look into the log files. And here you can see that my Quarkus REST service started in just 22 microseconds. And if I remember My last times, when I left IBM like 5 years ago, starting up WebSphere application server to serve a REST call, it was more like a minute or so, maybe 30 seconds. Yeah. So this one is really, 22 milliseconds. That is really insane. Yeah. And just to prove, we can also probably look into the memory consumption. The metrics are not there. Metric system typically takes a while to collect. So let me quickly prove that this is really running and doing. So this is exposed via a route, so I can take a look of it. So it is running. And I think it was there's even a Swagger UI client deployed to that REST stuff. So I could make a call, try it out, execute it, and it's responding to 100. Okay, content length 0. It's not responding, yeah, because it has no backend currently, but it's running. So, and to prove you really that it is running, let me quickly scale it down again. Quarkus REST, scale it down to 0. And if I reload, we will probably see that it's not running. Now you can see no response. It's not coming back because there's no pod running. And if I now do it in the other direction, scale it up like really, because it's just taking a couple of milliseconds to start it up, scaling it up is nice and easy. And if I reload now, you see it should be working again. Yeah. So yeah, lightning fast, subatomic, small, Java, really fast, really simple, really cool. Yeah, and there are, of course, a couple of extensions. The devil is in the detail because, for example, what do you do with reflection APIs? So it's not that so that you can use any Java framework just out of the box. You have to take a look and be careful. Simply go to quarkus.io, check it out, read about it, and see what's right for you. Okay, looking at the clock. Yeah, quite well in time. So much for the technical part. Let's come back to more of the political, open source, cultural, community stuff. What is it about with the CentOS story? So let me briefly explain the history. So, and I think I can skip the slides and go directly to this one. So if you look into the Red Hat Enterprise Linux ecosystems since 2014, so like 7 years ago, the general flow and community stuff was, so first of all, there was a Linux kernel, or there is a Linux kernel, with Linus himself still being the maintainer, but it's not the only project. There are tons of other projects for packaging, desktop, yada, yada, yada. And then there is the Fedora community, which pulls together out of this myriad of open source projects a Linux distribution. And so that's upstream community space. That is where the innovation happens, where you have frequent updates, architectural changes, major releases every 6 months. That's the upstream community space. And what we then from Red Hat did is that every couple of years, 3, 4, 5 years, we make a we pull the current Fedora release and pull it into our Red Hat Enterprise Linux with the idea to stabilize it, to make an enterprise product out of it, to provide long-term support, with really focus on stability, security, performance, and, for example, certifications for hardware, stuff like that. And also with a really predictable release cadence that the guys in the operational data centers, the ops guys, can plan when do we do the next update from RHEL 6 to RHEL 7, or from RHEL 7.1 to 7.2, the minor updates, all that stuff. So, and what we have since 2014 is that actually this is our enterprise product where you sell subscription fees for. But as we are being an open source company, and that we are also bound by the open source licenses, we have to publish what is the difference between Fedora and RHEL. So of course, we make the source code of RHEL publicly available. It's just the source code, so you have to do the building and getting the binaries out of it yourself. And that actually was CentOS Linux. So what the CentOS guys did is, they took our distribution and made CentOS out of it. So it is basically really close to binary compatible to RHEL. Not perfectly, because every time you compile, you get maybe some bits and pieces are different, but at least on a high level, it is binary basically the same. But it's free of charge. You can use it. Of course, there's no cost. There's no support, no certifications. You are dependent on the community. And if there is a major security fix, you have to wait until the community builds the fix. So it can take weeks, months for a critical bug fix to get. But that is your choice. If cost is your primary concern, then go for it, use it. Yeah, and that was the past until close to, I think the announcement was end of last year, earlier, beginning of this year, because we changed this model, and we changed it for a reason. Because the problem we are facing here is that RHEL itself has no open source community. So we have partners like independent software vendors, especially in the telco space, who would like to contribute to RHEL. They would like to see what is coming in RHEL 7.2, what is coming in RHEL 7.3. That was not visible because this development did not happen in the Fedora space. It happened in the RHEL private space. So it was not visible to the community. And we got feedback from a couple of organizations that say, guys, we would like to see what you are doing. We would like to contribute. Please change that. So we did change that. That's to this paradigm. So actually, and I think this one is a better one. Keep in mind, previously it was Linux, Fedora, RHEL, CentOS. And now we introduced CentOS Streams, which is upstream to RHEL. So this is now the community space where you can see and contribute to RHEL 7.8, 8.5, whatever it is coming. Yeah. So this is now an open source shared space where community partners can contribute, do, for example, early certifications of their hardware, their software. And it is an open source community. So Linux is still there, Fedora is still there, CentOS Streams is new, and RHEL is also still there. Still a private space. That's enterprise stabilized, highly secured enterprise distribution. And where the shitstorm entered, which actually got us a little bit surprised, is what basically happens is we were not aware of so many CentOS users who actually use CentOS in an enterprise productive data center manner. We were not expecting that, and as we are not part of yes, we are part of the CentOS community, but we actually we have no ways of understanding and learning. For RHEL, we know who downloads RHEL, who uses it. Yeah, but for CentOS, we didn't know. And it got us a little bit off guard, and also the communication was really bad. Because what basically happens is, so the original CentOS distribution will be end of life, I think, end of this year. So if you are running CentOS in production, and if you do nothing, you get up from the rock solid, long-term stable, security fixes are a little bit late, but I can work with that, really stable operating system, you are getting hooked to CentOS Streams, which is more upstream community, a little bit more fast moving. It's not as innovative as Fedora. Yeah, so the risk of breaking stuff is not that bad, but still it is a different beast. And that created a shitstorm that we did like, you promised that CentOS would be like 10 years there, which we actually never did really. There were some misunderstandings between individual persons making entries to certain mailing lists and websites, whatever. But yeah, that basically created a huge shitstorm, which we take. Yes, okay. We had a positive intent. We actually wanted to be more open with our stuff. That was our intention. But yeah, it caught us a little bit off guard. So in case you are using CentOS currently in a more productive way and are affected by this, what are the options and what are your ways of resolving this? So first of all, here's again some guidance on what to use for which use case. Yeah, like for example, you would like to do upstream community hardcore kernel developer stuff, go with Fedora. If you just want to use it as a developer program, go to developers.redhat.com if you would like it for your private home server, private development stuff. We have the Red Hat developer program where you can download it for free. You just have to register. Yes, you have to register, but there's no charge for it. If you would like to, for example, take part in the RHEL +1 development testing, you could use CentOS Streams. If you are into the container space and would like to have a rock solid, certified, security cleared base image, then the RHEL Universal Base Image is probably the go-to person. For mission critical workload, it's still RHEL. And if you need something to run on and would like to switch from CentOS to actual RHEL, yes, you probably have to go to a Red Hat salesperson and ask about what are the options. It is not that expensive. There are tons of programs for developers, for universities, for research. That is also an option. Yeah, switch to the real thing. If you get enterprise support, could be important if you run mission critical stuff. I wouldn't do this without, but anyway. And then, of course, there will be like what was CentOS in the past. It is still being possible to create such a distribution. And they are already gathering. I think I've heard of at least 2 projects doing the same, taking the source code that we still deliver for RHEL and set up a CI/CD pipeline build process to reproduce basically RHEL. I forgot the name of these projects. But there will be also community editions of downstream RHEL in the future. They will not be endorsed by Red Hat. Red Hat will not be involved in that. That's open source community, right? I mean, you have to stick to the rules, and it's possible to do such stuff. We have no problem with that. Yeah? We hadn't it in the past with CentOS. It's just our intention was to create CentOS Streams really as an additional intermediate community project where our partners who love RHEL can contribute to the next minor release. That is basically the only intention we had. So I'm surprised I was too fast. I'm kind of at the end of my presentation. That is the key messages that I wanted to convey. So I hope, Max, that there are plenty of questions out there. I'm currently not reading the chat, so what do you think?
Yeah, thanks for your presentation, Daniel, and these interesting topics. We indeed have some questions. The first question is, having VMs as first-class citizen with an OpenShift, are there still reasons to use a specialized virtualization solution like LHEV or ESXi?
LHEV is Red Hat Enterprise Virtualization, and in the long term, I would say no. This will converge. So, for example, we even actually announced that Red Hat Enterprise Virtualization is, let's say, functionally stabilized. So there will be no major feature and function enhancement. Of course, it will be maintained and supported for a really, really long time. but there will be no further enhancement because virtualization technology is more or less done. We will make sure that this OpenShift virtualization Cubeville is getting feature parity. So it is not yet there. I talked about live migration, that is already there. But for example, regarding PCI pass-through capabilities and so more specialized features of virtualization, there is still a little bit of features missing. But from release to release, we will get feature parity with existing virtualization techniques. You can actually do, for example, migrations. Let me quickly come back to this. I think I can show you this. If I switch back to my CNV project, for example, to migrate virtual machines out of Red Hat virtualization. Where are my virtual machines? Over here. So if I create a new virtual machine and I can import one, and here you can see that I can collect it, for example, to Red Hat Enterprise Virtualization or VMware, ESX, whatever. Currently, we are doing it for Red Hat Virtualization and VMware. So I can connect it over here. I have one configured, and now it takes a while because it needs to log into that. I wanted to say legacy virtualization technology, but I think it's premature to call it legacy. Let's say traditional, to the traditional virtualization environment, and then select, for example, virtual machines. Here you can see now I could, I think there is somewhere RHEL 8 demo virtual machines, and now I can import it. So in the long term, I think, yes, this will be converging to a single platform. And if you look, for example, into the competitive space, what VMware is doing with Tanzu, it's kind of the same approach, provide a unified platform. It's just the other way around. Like what VMware does is they take the virtualization technology and put container technology on top of it. And we do it the other way around. Yeah, but basically it's the same. It's the same approach to provide a hyper-converged, single, best of both worlds, one platform for everything.
Cool, yeah, sounds good, sounds good. Another question is, any disadvantages, limitations of using Quarkus over the usual JVM?
Yes, your mileage may vary. As I said, you have to be a little bit careful. So, for example, you cannot pull in any of this myriads of dependencies for Quarkus. If you go, for example, for the real Graal VM, here, the ahead of time compilation, there are limitations on especially the reflection API. You really have to take a look into the frameworks, dependency you use. If you stick to, for example, the Java micro profile, you are in good shape. Taking your existing traditional Java enterprise applications, let's say even with EJBs, it's probably not going to work. So my suggestion would be check out Quarkus.io and simply try it out. Yeah? You find out immediately, look into the community. There's a huge community going on this, and see and do a little bit of research if this or that dependency you would like to use, if this is working. So the answer is yes, it is. The devil is in the detail. I mean, if it would have been so easy, we would have done this like 10 years ago.
True. Another question is, what does Red Hat stand on Alma Linux?
On what Linux?
Alma Linux.
Alma Linux. To be honest, I don't know. I have to check it out. I have to take this offline. Do you have the name and the email address?
We just have user 31. That's it.
Please give us a name and an email address. And Max, if you could send this with a question to me. My problem is I'm the account solution architect for Siemens, and it's really, really difficult to keep track of what's going on, because that is just the tip of the iceberg. We could talk about multi-cluster management, advanced cluster security. So, for example, how can you deploy a single application to 500 clusters with just one click? If you think, for example, GitOps, GitSecOps, it's DevSecOps, GitOps approach, something like that. So there's so many stuff going on that I cannot follow each and everything. So, but I'm happy to do some research and get back and answer that question.
Cool, yeah. So we will see if user 31 wants to supply us the email address. We can surely.
If you would like to take this offline, user 31, daniel.fröhlich@redhat.com, send me an email, and I'm happy to. I think let me quickly hop to my daniel.fröhlich@redhat.com or simply dfröhlich@redhat.com. Here on the slides, you have my email address. Shoot me that question via email, and I'm happy to get back to that.
Yeah, let's do it this way around. Yeah, makes sense. Okay.
We have to respect privacy.
I think we are through with the questions. I don't see any more questions, right? No? Okay.
Excellent.
So then, thank you, Daniel, for your presentation and all the insights on the different topics.
Thank you for this really great and outstanding event. It's always a pleasure to be part of it.
Cool, yeah. Thanks for having me.
Yeah. Thank you. Stay safe. Try to get the vaccination and be careful. Bye.